In this series of videos, we're going to be discussing arrays. Arrays are ordered lists of values. So you can think about, for example, let's say you wanted to create 100 random numbers and store 100 random numbers. Well, you could certainly declare 100 integer variables, int num1, num2, num3, num4, num5, and so on. But if you don't really care about the individual names of those variables, that's kind of a lot of work to do. So arrays are an easy way to allow you to have situations like that where you have this group of values that has some ordering to it, but you don't have to give an individual name to each variable. You just give a name to the collection, and then you access each element within that collection by its position within the group. Okay, so the array itself has a single name and it can hold several values. Each one of those values is located at a particular numeric index within the array. An array of size n is indexed from 0 to n minus 1. So our arrays start at position 0 and they go up to and including position n minus 1. Now in Java, arrays can store elements of the same type. That type can be primitive, so it can be an int, it can be a boolean, it can be a char, or that type could be an object. So it could be a string, it could be an audio item, etc. But it can only store elements of one type. So you can have an array of integers, you can have an array of strings, but you can't have an array that has some integers and some strings. So arrays hold elements of one kind, one particular type, but again, that type can be either primitive or object. Now, the array itself is an object. Remember that all of our variables in Java are either primitives or objects, and that applies also to arrays. So arrays are objects. So when you give your array a name, because that variable is an object, what's stored in memory is a pointer or a memory location or a reference to somewhere else in memory where all the elements of that array are stored. So this is true whether the array holds primitives or whether the array holds objects. The array itself is an object. Okay, that's a really important point to remember when working with arrays, is that again, the overall array itself is an object. So let's look at how we would declare an array. So to declare an array, we specify the type that it's going to hold. Remember, all arrays can hold one type of thing. So we specify that type, then we put in square brackets, and then we give our array a name. So for example, we could say int array scores. So this declares an array of integers, so an array that holds integers called scores. So the type of scores is an int array, and every element held in scores is an integer. So this is going to hold a collection of integers. Note that scores is an object even though it holds primitive values, okay? But because scores is an array, scores itself is an object. The next line here, this declares an array of type string called names. So this is a string array called names. For this particular array, names, the array, is an object that also holds other objects because strings are also objects. And then here, let's say we had a class called course that described a college course, for example. We could have an array of courses, we'll call it the catalog. Again, catalog is an object and it holds course objects as well. Okay. So note that when we declare an array, remember that declaring any variable in Java means you specify the type and give it a name. In this case, we're specifying the type as int array, string array, or course array, and then giving those arrays a name. So for arrays, when you declare that array, it doesn't tell you how many elements it can hold, and it doesn't actually create any elements to go inside that array. All it does is it kind of oops, that's actually a typo. Doesn't actually allocate the space either. I'll update that on the slides. It just declares that array. Okay. Now, in order to specify how many objects you'd want to go inside that array, you need to initialize the array. Okay. So because arrays are objects, they get initialized with the new operator. So we use the word new, remember the new keyword, to set up new objects. So specifically for arrays, we use the new operator, and then we repeat the type, and then we put the size of the array inside of square brackets. So this is a little bit different than other objects. We don't call a constructor. Instead, we just allocate the space. Okay, so if we had that string array names, we could initialize that by saying it's going to get a new string array that holds 5 names. So this sets up allocate space for 5 strings. This doesn't actually put any elements inside the array, it just allocates the space. It just allocates enough room to store 5 strings, but it doesn't actually create anything. So it'll just pre-populate that space with null values. If we have objects, null is kind of the default that goes in there until we have an object to put there. So that's what we would put inside those 5 spaces. Let's say we wanted to hold 10 integer scores. We'd say that scores gets a new integer array of size 10. And let's say we wanted to hold 100 courses in our catalog. We'd say that catalog gets a new course array of size 100. So again, to initialize our array, we use the new operator. We specify again the type that's going to be held in that array, and then we specify the size inside of those square brackets. So initializing this array, again, sets up a place in memory. There's no elements in the array yet. There's just that much space allocated. Now, the one other thing that the new keyword does when initializing arrays is it sets up an instance variable called length. So remember that I said that arrays are objects. So technically it is allowed to have an instance data variable, and our arrays come with one instance data variable, and that variable is called length. Length holds the number of elements that can be stored in the array. Okay, so the largest index of the array is what? It's going to be length -1, because remember that arrays are indexed starting at position 0. So here's what it looks like in the previous slide when we had these 2 lines of code here where we initialized names, and this one here, and scores. So this is what it looks like in memory. We set up a place in memory that can hold 5 strings, so those are going to be indexed from 0 to 4, so that's our indices. These are our 5 positions, and it doesn't put anything in there yet, it just fills it with nulls, which I usually indicate in these memory pictures as just a circle. This is just null. It means there's kind of a holding place for a string. It's just an empty object. Now again, because names, the array is an object, what's stored in that place in memory is a memory location, reference, or pointer to wherever it is in memory that the whole contiguous group of elements is stored. Okay, so the names array itself holds a reference to the actual group of data. Now we also have this instance data variable length, and in this case length is 5 because that's what we initialize as the size of the array. So names holds a reference to a place in memory where those 5 strings eventually, a place that can hold 5 strings, index 0 to 4, and then we have this length. So if we said names.length, it'll give us the value of 5. Similarly, this is our integer array scores that can hold 10 scores, so index 0 to 9. There's no information in there yet. We haven't put any numbers in there yet. These are primitives, so I usually indicate that with a question mark. Again, the array itself holds this memory location to somewhere in memory where all of this array is stored, and then it also comes along with this length variable, which is 10. So the length is the capacity of the array. The array is indexed from 0 up to length -1. So just like with any other variable in Java, you can do these 2 things separately. You can declare on one line and initialize somewhere else in your program, or you can do it on a single line. So we could declare a double array called costs that's going to hold 100 double values. We could declare a Boolean array called flags that's going to hold 5 Boolean values. So we can do this combined on one line, or we can split it in 2 different places in the code. For both of these examples, costs and flags are objects because they're arrays, and all arrays are objects. And for both of these examples, the type they're holding inside the array are primitive. So costs holds the primitive type double, and flags holds the primitive type Boolean. So let's just declare and initialize a couple arrays. We're going to set up 3 arrays, one to store the first 4 prime numbers, one to store 3 names, and one to store possible letter grades A, B, C, D, and F. So I'm going to create a new class. Okay, so first we've got the first 4 prime numbers. So this is going to be an integer array. So I could do it on 2 different lines like this. This would just declare, and then I could initialize it in the next. Remember, to initialize, I assign that array to a new integer array of size 4. or I can do it on the same line. So I can say my string array words, I said hold 3 names, sorry, names, gets a new string array of size 3. So again, this is the type of the array. For primes, it's an integer array. For names, it's a string array. And then this is the initialization. This sets up that it allocates the space in memory. In this case, it allocates enough room for 4 integers. In this case, it allocates enough room for 3 strings. And what's held in the value of our array is a reference to this place in memory that holds those 4 integers, or this place in memory that holds those 3 strings. Okay, then my final array is going to be a char array to hold 5 characters, the character A, B, C, D, and F. Okay, so this is the declaration and initialization of 3 arrays. Again, all of the arrays are objects. This one holds primitive values, this one holds objects, and this one also holds primitive values. Now, once you create the size of an array, once you allocate that space in memory, you can't change it. Okay, so once it's set during initialization, you cannot change how many elements are stored in that space in memory. Okay, so let's say you've decided that somewhere in your program, let's go back to this little memory example here, we have our 10 scores, index 0 to 9. We decide we actually want to hold 20 scores. There is no way to sort of add on an additional 10 spaces to this array. Java does not allow us to do that, okay? Now, we'll look a little bit later at how we can sort of manipulate this and get around that, but just know that once you allocate this contiguous, meaning in order space in memory, you cannot change the size of it. You're kind of set with that size. Oops. Now, we can always find out the size whenever we want by accessing that length variable. So anytime we want to know the size of an array, the capacity of the array, we just access the name of the array dot length. So I can say, for example, the array will hold primes.length numbers. The first array. Okay, and that's going to tell us it will hold 4 numbers. Okay, so whenever we want to know that length, we can always access it by saying .length. Note a couple of things. First of all, length is an instance variable, not a method. So we just access it through the dot operator, but there's no parentheses. It's not a method we're invoking. It's just an instance data variable. So there's no parentheses. Also note that length returns the capacity, not how many spaces have been filled up. In our example here, none of our arrays have been filled with any values, but they all still have a length. So again, that length is sort of the capacity. It's the maximum number of elements that could be put into that array. It's not the number of elements that actually are in that array. Okay, so that's an important distinction to note. It's the capacity, not how many spaces have been filled. So again, remember about the indexing. Because we start at position 0, length holds the number of elements, but it's not the largest index. The largest index in any array is always going to be length minus 1. Be really careful about that. It's really easy to kind of make an off by 1 error and try to access the element at position length, but that's always going to be out of bounds, okay? The largest index in any array is always going to be length minus 1. Okay, let's take a break here, and in the next video, we've now declared and initialized our arrays, and we'll talk about how we actually use them.